Okay, for those that were absent on Friday, which is today, November 5th, 2021, I'm going to go over a problem that we did in class today from section 2.5, part 2. It says find all the zeros of the function. Okay, so here's our function. So before, we used to find the quadratic equation. We used to use the quadratic formula, completing the square, or just regular factoring for factoring. But this time, we're going to be factoring polynomials with degree 3 or higher. So for our first example, we have f of x equals x cubed plus 4x minus 5. Okay, so the first thing we have to do is find the possible zeros of the function. To do this, we're going to do p over q. P is all the factors of the last term, which is going to be plus or minus 1, plus or minus 5. And the last term, do not worry about this negative sign. We're just focused on the number. Over the factors of the leading coefficient. In this case, it's 1, even though you don't see it. So it's going to be plus or minus 1. Okay, so we got to simplify because it's of the form of a fraction. So 1 over 1 is 1, and then 5 over 1 is 5. So technically, we have 4 possible zeros that are real. Okay, but in reality, the cube tells us how many we're actually going to have. And the 3 means we can have real and complex. Okay, but these are just the 4 possible real zeros. So the next thing we're going to do is you're going to take your calculator, which I have here. I'll put it here actually so you guys can see what I'm doing. We're going to test the first zero. So we're going to test. Okay, so we're going to test 1. So in your calculators, I'm going to show you. We're plugging in 1 cubed plus 4 times 1 and then minus 5. That gives us a 0, if you guys can see. So that means that's one of our zeros. So because it's one of our zeros, I'm going to use synthetic division in order to find the remaining. So I'm going to put 1. Remember, I went over synthetic division in class, so you guys should be able to follow with me. So we're going to use the leading coefficients. And once again, if we have any missing terms, you're going to add a 0 placeholder. So we have 1, 0 because we don't have an x squared, 4, and negative 5. Remember, we bring down the first term. So 1 times 1 is positive 1. 0 plus 1 is 1. We repeat the process. 1 times 1 is positive 1. 4 plus 1 is 5. And we do it again. 1 times 5 is positive 5. And of course, this is going to be a 0. Okay, because that means 1 is our first 0. But whatever's left over is going to give us our complex zeros, which will have an I for imaginary. So remember, whatever's left over is always 1 degree less. So that's going to be x squared plus x plus 5. Okay, that's our remaining quadratic function. Now, because it's quadratic, make sure you apply the quadratic formula, which I'm abbreviating QF. Okay, so I know my A is 1, my B is 1, and my C is 5. So let's apply the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so we're going to continue to simplify. Negative 1 plus or minus the square root of 1 minus 20, because that's 4 times 1 times 5, all over 2. We have negative 1 plus or minus radical 1 minus 20 is negative 19, all over 2. Now remember, I taught this before. If you have a negative in the radical, you must take out an I. This is where the complex zeros come in. So therefore, x is equal to negative 1 plus or minus I radical 19 over 2. So I have 2 complex because there's a plus and a minus and 1 real 0. So therefore, my zeros, which I have 3 in total, are the 1 I found originally, and these are my 2 remaining. Don't separate, just leave it as 1. But technically, there's 2 solutions there that are complex. Okay? All right, so that's the end of the first example.